In match problem 4, we're still talking about the same company producing paper shredders. But now what we're given is a cost function, and we want to know what's the company's maximum profit, what should it charge for each shredder, and how many shredders should it produce. So a similar question, except instead of being concerned with revenue, we're trying to come to some conclusions about profit. So we still want to start this off the same way, by first establishing that function f of x that we're interested in either maximizing or minimizing. In this case, what we're interested in is finding the maximum profit, which can always be calculated as revenue minus cost, which in this case, our revenue is 300 x minus x squared over 30, which just comes directly from the last problem, that revenue function that we already calculated, minus the cost function, which is 90,000 plus 30x. So what we need to do is distribute that negative through our cost function, and then simplify so that we get negative x squared over 30 plus 270x minus 90,000. We need to make sure that we establish the domain for our function. In this case, we're still dealing with 0 less than x less than 10,000. So we're still just carrying over that same domain from our last problem, since we're still considering the same company and assuming they still have that same price-demand equation. So now we can establish the problem that we're interested in solving. What we want to do in this case is maximize our profit function, p of x, which is negative x squared over 30 plus 270x minus 90,000 on the interval from 0 to 10,000. Our next step then is to find all critical values. We do that by taking the derivative of our profit function, which will be negative x over 15 plus 270, setting that to 0 and solving for x is going to give us a value of 4,050 for x. And then with our critical value, we're going to apply the second derivative test. So we first calculate the second derivative of our profit function, which is going to be negative 1 over 15, which is less than 0 for any value of x, which implies that x equals 4,050. Or we could say that a little bit differently. We could say p of 4,050 is the absolute max. So we have an absolute maximum whenever x equals 4,050. And now again, what we want to do is take these mathematical results and phrase them in plain English to answer the basic questions that are being asked. So we know that our profit is maximized when x equals 4,050, so plugging that value back into our original profit function gives us 456,750. And when x equals 4,050, we could go back to that price-demand equation from the previous example, and we could find that our optimal price point would be $165. So our maximum profit of $456,750 is realized when 4,050 shredders are produced and sold for $165 each. So again, a final statement that's tying together all of that mathematical information to just make it plainly obvious. We want to produce 4,050 shredders. We want to sell them for $165 each, and that should yield our maximum profit of a little under $457,000.